Hi, welcome to the Applied Data Science course for beginners. I'm Gurami, and in this tutorial we will discuss practical part of logistic regression. Also, we will build a project which diagnoses whether a patient has a diabetes or not. Let's get started. Let's open Google Drive. I have Applied Data Science for Beginners folder, in which I have stored data folder and notebooks folder. In data folder, I store datasets, whereas in notebook folder, I store my Jupyter notebooks. Let's open notebooks, right click, and let's open Google Collaboratory. This will create your first Jupyter notebook. Let's wait a few seconds. Okay, now it's created and we are ready to start. Not to lose your time, I have written the whole code and let's discuss them line by line. You can pause the video at any time. In this notebook, you will learn logistic regression by doing a project of person's diabetes diagnosis. The notebook is mainly divided into two parts. In the first part, we will analyze and process the data. In the second part, we will create models. First, baseline model and then upgraded model. In the end, I will provide an exercise that you can do and share the result via our Discord community channel or GitHub discussion section. There is much to do. Let's get started. Because we are using Google Colab, we need to connect our Google Drive where we store our data in order to get access. To do so, we can just import Google Colab and we just write drive point mount and the text written inside. We can run the cell just by clicking here or pressing Shift and Enter. It will tell us to give permission. And now we will be connected. You can check it out by clicking here. And as you can see, here is another folder created. And here's the data in notebooks folder. After that, we need to import necessary libraries. Here we import pandas, seaborn, numpy, matplotlib. From scikit-learn, we import confusion matrix function, accuracy score function, etc. From preprocessing, we import minmax scalar class, and etc. You will understand why we need these functions and classes later. And let's run the code. Second step is to read the data. We can read the data just writing pd, which is pandas, point read csv, and the path of this dataset. In this case, the data is stored in our data folder. After that, we should always visualize what we read. Let's run this and let's visualize. As you can see, the data contains 9 features. 8 of them are input features and outcome is the target feature. Outcome represents whether a patient has a diabetes or not. In this case, each row represents the patient. It's a good practice to understand and check the data. What does it mean? It means that we should check whether it contains null values, missing values. We can check it just writing data point isNA point sum. Let's run this code. You will see that none of these features contain any missing values. In addition, we should check the data types of this data. In order to do that, we need to write data point data types. You will see that all the data types are int or float. In another case, if the data types are not int or float, we need to convert them into numbers because machine learning algorithms work on numerical data. After that, we need to visualize the data. Here, Seaborn proposes some good visualization of pair plots where we pass the data and the outcome as a hue. Let's run this code and let's pay attention to the output result. This visualization is really fancy. You might notice some correlations between features. And here, orange represents patients with diabetes and blue dots represent patients without diabetes. For example, we can look at this plot, which is a scatter plot and correlation between age and glucose. As you might notice, people who have diabetes have high glucose concentration. And let's make a naive, the easiest assumption that we can imagine. Let's say if the glucose concentration is more than 130, that person might have diabetes. Otherwise, they does not. Let's check our assumption with the accuracy scores. Before doing that, we can visualize the target features. We can just write data, outcome, the name of the target feature, and value count, which tries to count the ones and zeros in our target feature. We can visualize this kind of information with the bar plots just to have good understanding what our target classes look like. It's time to move on in the second part where we will build some models. First model, as I promised, is the baseline model. We can visualize the data first, and let's look at the data again. And what is the baseline model? We can make a prediction from the insights of the visualization and focus only the glucose concentration. And let's write data prediction. So we create another column and we write this npwhere. The input of this method npwhere is the condition and the output. This is our condition. And the condition is that if the data glucose concentration is more than 130, that person has a diabetes. Otherwise, that person does not have diabetes. Okay, let's run this code. And let's look at the data. Voila. You can notice that this is our prediction that we generated based on the glucose concentration only. We even did not use any other features. As you might notice, outcome, which is ground truth, and prediction, which is our prediction, has some correlations. For example, for the first patient, it guessed correctly. For the second patient also, third, fourth, fifth, and so on. Here, it could not guess right, but generally, it tries to guess it correctly. We can calculate classification metric scores now. We can store the ground truth array into y-test visualization and our prediction array to y-pred visualization. And we can just calculate accuracy score, precision score, recall score, as well as we can plot confusion matrices. Let's run this code. Okay, the result is really good if we only take into account one feature, which is glucose concentration. Here, the accuracy is 0.73, precision is 0.63, recall is 0.59. And the confusion matrices is like this. I will explain now what does accuracy, precision, recall, and confusion matrix mean. Here is the confusion matrix. X-axis represents our model prediction, whereas y-axis is ground truth values. From this confusion matrix, we can calculate the following metrics, such as accuracy, which is a fraction of a prediction our model got right. In this case, it's a division of summation of the diagonal over total number, which results 0.73. As for the precision, it defines what proportion of positive prediction was actually correct. And the result of precision is 0.63. And finally, recall is proportion of actual positives which predicted correctly. And it equals to 0.59. And it's time to use logistic regression. Let's visualize the data again, and we need to remove the last column that we created. You can just write data point drop columns equals to prediction, in place equals to true. In place equals to true means that we can remove prediction column inside the data and do not create any additional variables. Okay, let's run the code and let's visualize the data again. Okay, as you can see, the data is removed. In order to create machine learning model, we need to separate input features and labels. In this case, we can store input features in data f variable and output feature in labels. We can run this code. Because logistic regression is linear model, we need to do scaling of the data. We use min-max scaler, which tries to scale all the feature values from 0 to 1. In order to do that, we need to instantiate scalar object, and we need to use fit transform method, which takes the input of data f, and now we can visualize data and see what does this data represents. As you might notice, now the data values are changing from 0 to 1. In machine learning, it's always a good practice to do a train-test split. We need to train the model on some part of the data and validate our result on another part of the data, which is unseen for the model. We can do it by train-test split function, which takes the input of data f scaled, in this case this variable, labels. We indicate the size of the split. In this case, 80% will be training data and 20% will be test data. And random state equals to 42. I just set 42 because I like this number. This means that if I run the code several times, I will reproduce the same result of the split. Let's run this code. Okay, so training examples are 614 and test results are 154. This is 20%, this is 80%. As we splitted our data into train and test part, now it's time to build logistic regression. We instantiate the object of logistic regression class. We use fit method, which tries to learn the input. In this case, the input is x train and y train. We use predict method, which makes the prediction on the x test. And we use predict proba, which predicts the probability of each class. Let's run the code and let's look at the result. We see the prediction result, which is 0, 0, 0, and etc. We can see the ground truth. There are some correlations between prediction and test values. We can ensure this correlation with writing and calculating accuracy scores, which are the same as we did before. And let's run this code. Great. As you might notice, accuracy precision are improved. For example, here we had 0.73 and 63. Here it improved to 76 and 71. However, recall is decreased a little from 59 to 58. I showed you the power of the visualization. So even though we use the logistic regression, which is machine learning algorithm, I could not improve the baseline result too much. Now we can move on and connect our theoretical knowledge to practical one. As we discussed in our theoretical part, we have weights for each feature, W1, W2, etc., and the bias, which are learned in the end. We can see what is the values of the weights and the bias which logistic regression learned. For example, we can print the weights of the logistic regression by just writing lr.coef, and here are the values. We can print the bias as well. In order to understand them better, it's a good idea to visualize. We can print the input columns here as well, without the output column. And now let's print a bar plot. In the x-axis it's a columns, and in the y-axis there is coefficients. Let's print it. Great! From this plot you can see that the glucose have the highest impact on the prediction, the highest weight, as well as BMI and age. The least important weights are blood pressure, skin thickness, and insulin. We can take sample examples such as first patient, and let's see how it calculates the score behind the scikit-learn package. As you might remember from theory, the hypothesis function of logistic regression is 1 over 1 plus e in the power of minus bias plus weighted sum of the features. We can do the same operation and we can calculate what is the output from the hypothesis function. This is sigmoid function, and here we do multiplication of feature values, weights plus bias, and we insert all the produced result in the sigmoid function, which is 1 over 1 plus e in the power of minus x. Let's run this code. Okay, for the first patient, the probability of having a diabetes is 0.32. Let's do same prediction with LR object. Let's run this code. Okay, we got the same output. In this part of the tutorial, I just demonstrated how scikit-learn library calculates prediction probability. Don't worry if you don't understand all the methods and functions from the pandas and scikit-learn library. That's how we learn by doing. This is the exercise you can do. You can download the data from this link and store in the Google Drives folder. I will just help you to read the data because it has a little bit different structure. We will do the same pd read csv and the path of this data, which is stored in our drive right here. Let's run this code and visualize the data. We have 61 columns. First 60 columns are input features, and the last column are just target feature. As you might notice, these are not numbers, these are letters. In order to run machine learning model, we need numerical data. So I will just convert this textual data into numerical. I will see what is the distribution of target values. In this case, we have 111M and 97R. And I replace R with 0 and M with 1. Let's run this code and let's visualize the data again. Alright, all the features are numerical now. Now it's your turn to do a classification using logistic regression. You can also do evaluation using accuracy, precision, and recall scores, and share your result in the GitHub discussion section or Discord community channel. If you are stuck in something, you can also post the question in any time. It is the end of the tutorial. We have built a machine learning classification project using logistic regression. I hope you liked it. In the next tutorial, I will discuss theoretical part of one of the popular machine learning algorithms, this Gen3 classifier. Make sure you subscribe in order not to miss it. See you in the next video.